this is John from kvalveprogramming.com, and this is a tutorial on inheritance in Java. So at the end of the last tutorial I said we'd look at the equals method in this tutorial, but I realised that there are some things about equals which, to understand them, it helps if you know a bit about inheritance. So I'm going to postpone the equals tutorial, and we're going to look here at the very important topic of inheritance. And I just want to take a little moment just to thank everyone who's left comments. Your comments really motivate me to create these free tutorials, and they are very much appreciated, so thanks very much. Okay, so let's create a new class here. I've got my main method set up in this kind of class in Eclipse. And so far in these tutorials I've been creating classes in the same file, but I'm going to switch now to creating classes in separate files, which is what you will do most of the time in your programs. So let's just expand this, and I'm just creating everything in the default package here, and we haven't covered packages yet. So I'm going to right click actually the source folder or the project folder, it doesn't matter, and go to class. Apologies for the background noise, by the way, because people are working on the flat opposite mine, and wherever I go there's always someone renovating an apartment nearby. Okay, so let's create a class here called machine, and click finish. And now, just because just from saying public class machine in a file called machine.java, I can already create objects from that machine. I can create a variable of type machine, so machine, call it Mac1. I can say new machine, like this, which actually allocates memory for my machine object, and I can combine those also into one statement by saying machine Mac1 equals new machine, which is what you do most of the time in Java. And let's give this machine some methods. So I'll give it a public void start method. Let's imagine that all machines can be started, and I'll say sysout here. And for some reason my sysout shortcut's not working, so I'll say system.out.println, and I'll just copy that, and because I'm going to use it again later. And let's say here machine started, like this, and I'll also give it a public void stop, like this, and in there we can say machine stopped. Okay, so I can now call those methods using this variable which I pointed at my machine object. So I can say mac1.start and mac1.stop, and since those methods are just doing sysouts at the moment, if I run that, it's just going to display some stuff in my console here, which is coming from here. So you need to have a good grasp of defining methods and calling them before you move on to inheritance, really, otherwise you'll get confused. And what I'm going to do now is create a new class. So let's right click the project folder again, go to new class, and let's call this car, and click finish. Now of course I can create variables of type car. Let's call this car1, and I can point those at car objects. Let's have one object here, and car has no method. If I do car1 no methods, well actually it does have a few methods, and these are actually inherited from a class called object, which is actually the ultimate ancestor of all objects in Java. But aside from those, there are no methods that I've defined here. But supposing I go to my car class now, and I say car extends machine, and what that means is that car is a child class of machine, or machine is the parent of car. We can say that car is derived from machine, or that car is a machine, or that car inherits from machine. This is all good terminology, and what this means is that now a car is already identical to a machine. So now I can say car1.start, and car1.stop, the fact that I've said public class car extends machine means car has now got all the methods that machine has. Now of course we can add new methods to car. So I've got my car child class, which inherits all the methods of machine, and I can add more methods to it. I can say, for example, public void, I don't know, wipe wind shield, and let's give that some functionality. I'll just put another sysout in there, and I'll say wiping windshield. So now of course car is identical to machine, except that it's got another method now that machine doesn't have. So I can say let's put it between start and stop, car1.wipe windshield. So this is inheritance in action. Even if you've got a class which you don't have the source code to, usually, except for under certain particular circumstances, usually you can extend it to create your own version of it, and then you can add new methods to it, which is really useful. You can't do that with some classes. For example, the string class is it's a final class, and it can't be extended, but most classes you can extend. So another thing you can do is you can override methods. I'm just going to touch on the basics of this here, but here for example we've got a public void start method, and let's copy that and go into car and paste it in, and change this to car started. So what I've done here is I've got a method in the parent class with this header public void start, takes no parameters and returns only void, and I've defined one exactly the same as that in car, and it's important that the header part of the method should be the same if you want to override a method. And now when I call start in car, it's going to call the car specific version rather than the machine version. So we say that this method has overridden the method in the parent class. It's basically replaced it. Now there's quite a bit more to say about inheritance, as you might imagine, but I'm just going to probably show you one other thing here, and before I do that actually I'm going to delete that and show you a better way of overriding a method. And this is Eclipse specific, but there are similar techniques that you can use, similar shortcuts in any decent IDE. So NetBeans or IntelliJ IDEA, possibly not BlueJ, which some university students are forced to use, and it's no offence to the creator of it, but that's an IDE that's well out of date by now, in my opinion. Anyway, I'm going to right click here within the body of car, and I'm going to go to source, override implement methods, and I'm going to click so these are all the methods of machine, and you can see methods of object as well, which is secretly the ultimate parent class of both machine and car. But let's say I want to override the start method in machine. I just click start and click OK, and it fills in the method for me together with a stub. This is actually calling the corresponding method in a parent class, so this would mean that car still has a start method, but it just does it just calls the parent class version, basically saying machine started. But if I get rid of this body now, I can put my own stuff in there. Whoops, didn't want that. Let's just copy this, being as my sysout shortcuts mysteriously stopped working, and put in here car started. So we've overridden this just as before. So the shortcut for that is right click in the body of your class, go to source and override implement methods in Eclipse. Now you'll notice Eclipse puts this, it's called an annotation. It's an @ sign, and the override, this is actually a class name here, which is why it's got a capital O. But we're not going to worry about that now. But the bottom line is, if you put an @ sign and override with a capital O before your overridden method, it will check that it really is an override. So if I misspell this now, it will complain and say, start is not in fact a method that exists in the parent class, whereas without that override annotation, of course it would just create a new method called with a different name, which wouldn't do anything because I'm not calling it at the moment. So if you want to override a method and you want to check that you really are overriding a method in the parent class, then putting this annotation in just helps you spot errors, but it's not necessary. So one last thing for this tutorial, I just want to say quickly a bit about variables, because if we've got like if I've got a private string name in machine, let's set that to I don't know, I am a machine, or maybe it would be more appropriate to say machine type 1. There we go. Now because I've declared it private, this variable can only be accessed within this machine class. So if I went to car, the child class, and let's say I created a method public void show info like this, and then supposing I had a sysout and I tried to access name in there, so let's say car name plus name, it's going to give me an error there. It's saying the field machine.name is not visible, and that's because I've declared it private, and we're going to look at public, private and protected a little bit more in a future tutorial all of its own. But if you declare something private, it's only accessible within the class, so that means within these brackets, the bracket that opens here after the name of the class and that finishes here, you can only access this name within here. But if you get rid of private, you can now access this anywhere within the package that machine is in, and we haven't looked at packages explicitly yet, but car and app are both within the default package here, so you can now access it. And if I run this, well, let's call that method, let's say car1.showInfo, and run that, then you'll see car can access it, car name machine type 1. I was wondering where car name came from, but of course I typed it here. Okay. And if you want to give this an access specifier, which you really should ideally, you can make it protected, and protected means that you can access this anywhere within the package and also from any child class, so this will still work. So I just wanted to show you that quickly here, and we're going to touch on it more in future tutorials for sure. Don't be tempted to try to override variables, because the results will be horrible. It's not a good idea. You should only override methods. Okay, so that's it for this tutorial, and in the next tutorial we're going to take an initial look at interfaces in Java. So there's a lot to say about interfaces, but we're just going to make a start on them in the next tutorial. So join me again then, and until then, happy coding.